Okay, welcome guys. This is Mr. Ndabezita, and this time we will look at polymorphism. Right, polymorphism is best explained with an example. So I'm going to delete all this, and I'm also going to delete this, and I'm also going to delete the person. Imagine how the universe would be if we didn't have a person. The universe would have never been in the state that it is in today. The universe, the environment would have the capabilities of reforming itself and getting back to the abusos stage. A person is a problem. Right. What I want us to do is to look at polymorphism, and polymorphism is one of the main object-oriented programming principles. Right. Polymorphism is the ability to take many forms. One thing taking many forms, being used in many different ways. This is what polymorphism is all about. And we have compiled time polymorphism. We will look into this, and then we will see how this truly happens. So compile time of polymorphism occurs in the function overloading. So we dealt with function overloading, but I think even in this tutorial we will try to look into that. Right, example of function overloading: many functions with the same name that accept different arguments. This is what we call function overloading. So you have, for example, this method. The first one takes in one argument, the second one takes in two arguments. We dealt with this even with the constructors. Overloading your constructors. You have a default constructor, you have a constructor that accepts 1, 2, 3. We dealt with all this. Papa Fanzo, please do not speak this much. We understand that. Right, it is best demonstrated with coding. So what I'm going to do, I'm going to create a class, and this class, I will just call this class the summator. The summator, summing two things, adding two things and finding the result of that. So one thing that we will do, we have this summator class, and what we will do is just to have, oh Jesus, one is tired, let's have a public method which will be of type double, and we will call this the sum. This method will accept a double argument, which is num1, and will also accept a double argument, which is num2. And then inside of the body, I just want to return, because remember it returns a double, and I just want to return num1 plus num2. I'm just adding those two numbers whenever you pass those numbers, right? Okay, that's fine. Remember, we want to do overloading, method overload. So I am going to use the very same name here. Just copy this line and just paste. And now this one will have a double num3. And it will never complain. I can use the same names with a different number of arguments. And here I just wanna add that. And everything is fine. Everything is just fine. And I can go to the main. And when I am inside of the main, I will go to my summator, and I will call this the summator is equals to that. Right. Now let's go to the summator. Do I have a constructor in here? No. So a default one will be created for me. Right now, when I am inside here, I just want to have a right line, and in this right line I will just say, okay, let me just use interpolation, and in this interpolation I will say 1 plus 2. In fact, let me not say that, let me say let me just do this. Let me do this. Let me just say I have this summator, so I'm going to say summator dot. Okay, no, let me not do that. Please let me not do that. Let me just say 1 plus, okay, let me just have some space, 1 plus 2 equals, and let me just say summator dot sum, and let me just send in two values, which is 1 and 2. So I'm saying 1 plus 2 equals that, and I'm sending 1 plus 2, and I can copy this and paste. But this time I'm going to say not 1 plus 2, I'm going to say 3 plus 4 plus 5 equals, and I'm going to pass in here, I will just pass in 3, 4 and 5. This is what I will pass in there, and when I run this I will have the following. So this is 1 plus 2 plus 3 equal 1 plus 2 equals 3. This equals 12. So what is this? This is runtime polymorphism. What happened now? Okay, sorry, let me just rerun this. So we have that. So this is runtime polymorphism, or we can say compile time polymorphism. So we are compiling, and the method takes in many forms. Here it adds 2, the same method here adds 3. So this is compile time polymorphism. Okay, that's fine, and nothing new about this. Now, runtime polymorphism occurs in function overloading. Right. This means that the base class has a function that's being overridden in the child classes. Very important. Runtime polymorphism occurs in function overriding. You are overriding a function. This means that the base class has a function that's being overridden in the child classes. And how do we demonstrate that? I'm going to come here, add a class, and I'm going to call this class a figure. This is the name of the class, it's a figure. And this figure, I'm going to treat this as the base class through which the children will inherit from. So the base figure, the base class will have a public double, and I will call this calculate area. It's a method. And remember it's of type double, so it will return 0 because there's nothing to be calculated there. We don't have anything, we don't have parameters that will be accepted, and so that it can calculate that. So this is all what we are saying. Right. Now this figure, I know that a square is a figure. So I'm going to create a class that I will call a square. And a square is a figure, therefore inheritance will be applied here. So a square will inherit from what? From a figure. Right. A square will inherit from a figure. What does that mean? It simply means that it will have access to this method calculate area. And we are going to calculate that area of this square. Right. And then one thing, I will have a private double, and I will just have a side. This is just a field. And I will have a constructor public square that will accept double side. Let's go to the figure. Do we have a constructor in here? No. But inside of a square, we are having a constructor, and because I'm using the same names, but I don't want to do that, I want to say side value there. Side value there, so that I can get rid of this. Oh Jesus. Right, let me just get rid of this. Right, I have this side which is equals to the side value. Okay, just to keep track of everything, let me just end a class. Right, once I have constructed this constructor that accepts one argument and assign that to the private double, I want to override the base method. So what I will do, just not to make any mistakes, I'm going to copy this. And I'm going to go to a square and I'm going to paste that. And let's hover over here and check. Square.calculate area hides the inherited member. Figure.calculate area. Use the new keyword if hiding was intended. Yes, hiding was intended. So what I'm going to do, I'm going to say public override double calculate area. Right, but it should not return, not all code path returns a value. So it has to return a double, and I'm going to say return, because I know to calculate the area of a square, it is a figure that has all sides equal. That's why I'm only having one side. So I'm going to say side multiplied by side. So that's how you will calculate the area there. And then it's complaining, cannot override the inherited member because it is not marked virtual, abstract, or overridden. So let me get rid of this. So let me just get rid of that. Right, and when I get rid of that, I don't have an error. It will just say square what and so on. So in order to maybe do things in the right way, the way in which I was taught in the university by professors, the first occurrence of a method, you make that virtual. So this will be a virtual method. And then here you can now use the override. And you see now the error is gone. This is how I was taught this by the professors of university. Okay, that's fine. We will return side by side. And then I'm going to create a class, and this class I will call a triangle, because I know that a triangle is a figure. Triangle. Right, the triangle will also inherit from a figure. Right, and then in order to calculate the area of a triangle, okay, let's just say this is a right angle to triangle. All right, let's just have a private. Let's just have a private double. Let's just say we have a side A, and I'm going to use a comma here, B and C. Let's say we have all those sides and they are all private. And then one thing that I'm going to do, let me just end the class. So here I'm not commenting in a professional way. I'm just commenting this. I'm just saying end the class. I could have said end the triangle class and so on. So that is going to consume some time. So I will create a public constructor which will be a triangle, and it will accept a few things. It will accept a double, a let me just say a value, and it will accept another double, and this will be the B value and the C value. Autocomplete Visual Studio 2020, what is it, 22 or 23? I don't know, but it is super good. Right, and then I'm going to say that this is equals to that, and I will wait for autocomplete. I Jesus, I my Father and my God. Right, and then I don't have to use this because the names are not the same, and I just have that. Coding and simplification at the same time. All right, and then from there I want to override the base method, and the base method, I know it's in here, so let me just copy this, go to a triangle and just paste that, and I'm going to say override Jesus. Now the first thing I'm going to do, I am going to calculate first the perimeter of this triangle. So I will have a double P, which is perimeter, and I know that the perimeter of a triangle, you add the sum of all those sides. Right, it depends on what type of a triangle you are dealing with, but the one that I'm dealing with, you will have to say A plus B plus C and divide all that by 2. And I know that the brackets Botman's rule will be used there. Okay, that's fine. And then I can calculate now and say double. I can say double area it's equals to maths dot square root, and what square root, I'm going to take P and I'm going to multiply that by the difference of P minus A. Very good. And I will multiply that by the difference of P minus B, and I will also multiply that by the difference of P minus C, and I will just close that, and I will just return the area. Very, very important. And then to test my program, I can go to the main and in the main I will just get rid of that. And one most important thing, I will create an object of square, which I will call square equals new square. And I know that the constructor of a square accepts a side, and this side is 2, because when you go to a square here, remember the square, in order to calculate the area, it will need a side, right? And then I can come here, and then once that is done, I can have a right line, and in this right line I can say square area equals, and I can use concat, and I can say square dot, and I must have calculate area there it is, right? Okay, that's fine. And then secondly, I can create an object of a triangle equals new triangle, and it accepts 3 things, and then I'm going to pass in 3, 4 and 5, right? And then from there I'm just going to have a right line, and this right line will just say triangle area equals plus, I will say triangle dot calculate area, and it will calculate that area for me. And let's just check that. Let us just check that. And when we check that, we found the values to be in that way. So this is all what I wanted to share with you, wonderful people. And this was just polymorphism. So I will see you in the next tutorial.